Hi guys, we're back again today looking at section 5556. I know that's what we've been working on the last couple days, but that section actually has a lot of info in it. We combine them together because they just fit together. You can't even really tell where the difference is between one and the other. Today though, we're looking at how to write a polynomial function given its irrational and imaginary zeros. Remember, zeros are just answers. Now, we've done something similar to this already, so the concept of it should be pretty familiar. It's just a matter of setting them up in the right way. Also, I apologize for the turkeys on my notes. I never did change those from last semester, so sorry about that, but you can enjoy the little turkeys. I mean, he's really cute. So to look at him. All right, so kind of talking through the highlights here. We talked about complex numbers. Complex numbers, that's when we're looking at numbers that have an I in them or they have a radical in them. Okay, so it's a lot of fancy words here, right? All this is telling you is that if you have a positive answer that has an I or a radical, then you also have its negative as well. Pretty much think about it this way. They come in pairs, right? It says down here they come in pairs. Like if you're solving something, let's say you had x squared equals -4. Sorry about my terrible handwriting. -4. And I asked you to solve that. You would take the square root of both sides, and then you would tell me x equals plus or minus 2i. Right? Because anytime you take the square root of something, you always have a plus minus. So anytime I give you an answer, like if I told you one of the answers to something was a negative radical 3, what other answer do we know has to be there? Well, you also has to have a positive radical 3. Because anytime you have a radical, you have a plus minus in front of it. So if they give you one of those saying that, hey, one of the answers is radical 3, well, I know then also negative radical 3 is there. Kind of the same thing with the i's, right? Over here, in order to get an I, that's when there's a negative underneath a radical. So taking the square root of that, I took the square root. So that's why I have a plus minus, and then whatever my answer is, in this case, plus or minus 2i. So anytime you have radicals and you have i's and their answers, then we know you also have the opposite one. If I have a positive I also have a negative I. If I have a positive radical 3, I have a negative radical 3. Okay, so they come in pairs. So knowing that they come in pairs, again, when we take the square root, just kind of reiterating my point here, anytime you take the square root of something, you always have a plus minus. Since we have a plus minus anytime we take the square root, that's why we know that they are coming in pairs. All right, so if a fourth degree polynomial, so fourth degree, I know has 4 answers, has roots of radical 2 and 1 plus I, what are the other roots? Well, I know if it has a positive radical 2, it also has to have a negative radical 2. In other words, we know that answer would have been a plus minus radical 2. We know that's 2 answers. And likewise, if I have 1 plus I, then I also have 1 minus I. Because again, we would have written as 1 plus or minus I. We always just write the, lazy man math, right? We'd write plus minus instead of writing them separate. So here's 1 answer, 2 answers that they gave us, and then here's 3 and 4. So I have my 4 answers. If I have the positive, I also have the negative. So number 2, could a third degree polynomial with rational coefficients, everything we're doing here is going to have rational coefficients. Coefficient is just a number in front of x. Rational means it could be written as a fraction, and that's all we've been dealing with. So don't get hung up on that terminology. Everything we do is going to have that. So you can almost kind of bypass it at this point. But anyway, could a third degree polynomial have roots of radical 3 and 2 minus I? Well, let's kind of stop and think. If they gave me a positive radical 3, I also know I have a negative radical 3. They have to come in pairs. And if they gave me 2 minus I also have 2 plus I. i's and radicals always come in pairs. So I have 1, 2, 3, 4 answers. Could a third degree polynomial have 4 answers? No. It would have to be a fourth degree because it has 4 answers. All right, number 3. What is a third degree polynomial that has roots of 5 and radical 2? All right, now this actually wants to know what is the polynomial that has those answers. So again, I know that I have a radical 2. I also have a negative radical 2. So I'm lazy, and you're my students. You guys know this. I always tell you that. I'm just going to go ahead and throw that plus minus sign right in front of it. Okay? I know that I have a plus radical 2, a minus radical 2, and 5. 5 doesn't come with a pair, right? Just because I have 5 doesn't mean I have negative 5. All right? I have a 5, and that's it. Radicals and i's come in pairs. All right, so in other words, it wants you to write the equation in standard form for whatever equation this came from to give me those answers. We've done this before. Y equals, where does 5 come from as an answer? Well, we know that came from x minus 5, right? Because if I had x minus 5 equals 0, and I asked you to solve this, you would get x equals 5. Okay, so that same idea, how on earth do you get plus or minus radical 2 as an answer? So I know that's 2 answers, so that's going to be x squared. And in order to get that, you have to kind of stop and think, where does that come from? Well, that would have came from an x squared minus 2 equals 0. And let me show you. Because if I was going to solve this, I would add 2 and get x squared equals 2. And then I would take the square root, and I'd get plus or minus radical 2. Okay, so x squared minus 2. All right, now the form I'm in right now, this is in factored form. Don't stop here. We want to keep going to change it back into standard form. That's why when it's asking on that last one about rational coefficients, in other words, put it in standard form. Okay, actually multiply this thing back together. So we're just going to go ahead and distribute. So we get x cubed minus 2x minus 5x squared plus 10. And see if we have any like terms, which we do not. But we always want to make sure we leave our answers in standard form. So this is not written in the right order. So it would be x cubed minus 5x squared minus 2x plus 10. And this is the third degree polynomial. See, it's third degree, right? Third degree. If I would go ahead and solve this, then I would get the answers of 5 and plus or minus radical 2. All right, number 4, write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. Now, that is the full-fledged directions. There's a lot of big words and a lot of fancy terms in there that kind of gets overwhelming. And those of you that had read through directions and be like, wait, what am I supposed to do? All that really means is, what polynomial did this come from? What is a polynomial that would give me these answers? So we're just going to attack all these problems the same way. But now you see the directions, you understand that what they're actually asking for, okay? So let's go ahead and just jump right into it. So y equals, we know 7 comes from x minus 7. And I have a negative radical 3. I know that I have a positive radical 3 as well, because radicals and i's come in pairs. So that will have come from x squared, and it'd be minus 3. All right, again, x squared minus 3. If I would solve that, you would add the 3, and then take the square root, so you'd get plus or minus radical 3. Now, before I move on to finish this problem, I know some people can visualize that, they can see it, no big deal. And then other students have the hardest time trying to figure these out. So anytime you have a radical answer, and we know they're always plus minus, they will always get set up as x squared minus, so no matter what's going on out here, because we know there's always plus minus, if it has a radical, it is always x squared minus, and then it's the number under the radical. Right, if you notice here, it was plus or minus radical 3, and I ended up with just x squared minus 3. And you can see why, if you look over here, why that works. We want that to be a minus sign, because that way I can add it to the other side, and I don't end up with a negative under a radical, okay? So if you have a radical, they are always minus, always, no matter what. Everybody got that? It's a radical, always a minus. All right, so let's go ahead and multiply this thing together. We will get x cubed minus 3x minus 7x squared plus 21. I don't see any like terms, but again, it's not quite in the right order, so we'll just rewrite. So we get x cubed minus 7x squared minus 3x plus 21. And we're good. All right, number 5. Same really long, lengthy directions. In other words, what equation did this come from? So we're going to work that back. So y equals, we know 3 comes from x minus 3. And I see a radical, so I know there's a plus minus in front of it. And it's going to be x squared. We just talked about radicals are always a minus, and then it's just the number under the radical. Anytime you're not sure if you set it up right, do a little note off to the side. Solve it. So I'd add 5, take the square root, so x equals plus or minus radical 5. And you're like, oh yeah, that's exactly what I wanted. So if you're not sure, do a little note off to the side, solve it, and be like, okay, that's actually what I wanted. All right, and then we just distribute. So we get x cubed minus 5x minus 3x squared, and that would be plus 15. And then no like terms, but again, we're in the wrong order. So x cubed minus 3x squared minus 5x plus 15. And we're done. Now, if you remember back when we were doing this before we had radicals and i's in there, we always checked them, right? You could graph them in your graphing calculator, or you could graph them on Desmos if you don't have a graphing calculator or you didn't download the app like I asked you to. But you could always graph them, right? Hit y equals, type in your answer, right? Type that in your calculator, and then look and see where it crosses the x-axis. Okay, we should definitely see it crossing at 3. And then radical 5, you're going to have to go ahead and see what is radical 5, right? It's 2 point something. So you should see it crossing at a positive 2 point something and a negative 2 point something. Okay, but you can kind of do that little double check as well, just like we did before by looking at the graph. All right, same long directions, same idea, jumping right in. We just have more pieces this time. So y equals, negative 3 comes from x plus 3, 3 comes from x minus 3, and a radical I know is plus minus, so that's going to be x squared. Radicals are always minus, and then the number under the radical. All right, and then if you remember back when we taught this before, when we were just multiplying them all together, remember this was the section that wasn't hard, it was just tedious and time consuming. We're back to that again. But I always started with the back 2. You could have started with any, just my own preference, start with the back 2 and kind of work my way through. So multiplying here, we get x cubed minus 2x minus 3x squared plus 6. No like terms. Order, I'll worry about that later. We're going to drop this one down. And now we're going to multiply these together. So we get x to the 4th minus 2x squared minus 3x to the 3rd plus 6x. And then we'll distribute the 3 plus 3x cubed minus 6x minus 9x squared and then plus 18. Whew, we get some long problems going in here. All right, clean up our like terms and put it in the right order. We have an x to the fourth. Let's see, I have a minus 3x cubed plus 3x cubed. Well, those are going to cancel out. And then negative 2x squared minus 9x squared is negative 11x squared. 6x minus 6x, those are going to cancel. And I have a plus 18 on the end. And we are done. There we be. All right, one more of these. Let's see how we do. So y equals 2 comes from x minus 2. 0, do you remember where he comes from? That's baby brother, right? Out in front. And then I see a radical. I know radicals are plus minus. All right, so we are going to, oh, sorry, almost sneezed. All right, so then we're going to have x squared. Radicals are always a minus, and it's the number under the radical. And now we can multiply this together. So we're going to have x cubed minus 8x minus 2x squared plus 16. I'm going to drop down my x and we'll multiply him. So we're going to have x to the fourth minus 8x squared minus 2x to the third plus 16x. All right, like terms, I don't see any. However, it's not in the right order. Darn that order. So we have x to the fourth minus 2x cubed minus 8x squared plus 16x. Just remember when you're reordering, like this is a negative 2x cubed, so that minus is going to come with it. Okay, just like that negative is in front of that 8x squared, and that's attached to that as well. Again, if I was checking this, I would be looking at, I would graph it, and then I would look and see, does it cross at 2, does it cross at 0, and does it cross at whatever the decimal expansion is of plus and minus radical 8. Okay? All right, so that was radicals. Let's then talk about i's. If you're feeling a little overwhelmed right now, take a break, hit pause, go maybe take a little break, take a walk, eat a snack. You could even practice the homework on just the radicals if you want at this point, and then come back and look at I. If you're doing good, let's just power on through, okay? So if we're looking at I, same idea. We're going to have y equals, we know negative 4 comes from x plus 4. Now, we know the I is going to have a plus minus, so I know it's x squared, because I get two answers. Where does 2i come from? In order to get 2i for an answer, it needs to be plus. That way when you solve it and you move it to the other side, it becomes a negative. That's where the I comes from. And it's going to be 4. Right? So if I had x squared plus 4 equals 0, I would subtract the 4 and then take the square root of both sides. And that's where you're getting the plus or minus, oh my goodness, sorry, plus or minus 2i. Okay? Again, some people are great at reasoning, some are not so great at reasoning through that. So if you have an I, when you do these, right, we know they're plus or minus. It's always going to be x squared, and then it needs to be a plus sign, and then you will square the number with I. So like on mine, I had 2i, 2 squared is 4. That's where that came from. That way when I take the square root of it, I end up with the number over here that I wanted. Okay, I also like goofy ways to remember things. I always remember that I am a positive person, right? If as an I know it is a plus sign. I am a positive person. I know it's annoying and obnoxious, but it helps me remember it. All right, so that's in factored form. We will distribute. So we get x cubed plus 4x plus 4x squared plus 16 I don't see any like terms, but again, these are in the wrong order. So y equals x cubed plus 4x squared plus 4x plus 16. Now, if you're thinking about checking this one on a calculator, if you graph it, again, you were graphing your answers, and then checking, it should cross at -4, and that's it. Remember, I, for an answer, any imaginary answer, it does not cross the x-axis. So the only place it should cross is at -4. All right, number 9. All right, I see an I, which I know is plus or minus. All right, so we have y equals, I know it's plus or minus, so it's x squared. I am a positive person, helps me remember that should be a plus sign. And then you square the number with I. There's a 1 in front of there, so 1 squared, 1 times 1 is 1. And then -7 comes from x plus 7. Again, you can always double check. X squared plus 1 equals 0. It'd be x squared equals -1 square root. That would give you plus or minus 1i, or just I. All right, so then we distribute. So we get x cubed plus 7x squared, oops, plus 1x plus 7. I do not see any like terms, and this time they are in the right order, so I am done. If I'm looking to check this on my graphing calculator, it should cross at -7, and that is it. All right, we got 2 to go. All right, so number 10, setting it up. -5 comes from x plus 5. 0 is my baby brother of x out in front. An I has plus or minus in front of it. So we're going to have x squared. I am a positive person. And then you square the number with I. 6 squared, or 6 times 6, is 36. All right, so there it is in factored form. I'm going to start with the back 2 and give me x cubed plus 36x plus 5x squared plus, there we go, 36 times 5 is 180. And then we will bring down this one, and now we can multiply through here. So we're going to get x to the 4th plus 36x squared plus 5x to the 3rd plus 180x. And I don't see any like terms, but my order's wrong again. So y equals x to the 4th plus 5x cubed plus 36x squared plus 180x. Checking on the graphing calculator, if you type in your answer, it should cross at -5 and 0, and then that is it. Nowhere else should it cross, because that 6i plus or minus 6i, those two answers are imaginary. All right. Write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. Whew, those directions are a mouthful. But we know how to tackle this now, right? So when I see that I know it's plus minus. I'm going to throw that out in front. So y equals, since it's plus minus, I know it's x squared. I am a positive person, helps me remember that. Square the number with I. 3 squared, or 3 times 3, is 9. 8 comes from x minus 8, and 2 comes from x minus 2. All right, starting with the back 2, we get x squared minus 2x minus 8x plus 16. I see some like terms. I'm going to go ahead and clean as I go, something my husband does not do when he's cooking in the kitchen. Oh, it drives me crazy. If you clean as you go, it's a lot easier at the end. Anyway, drop this one down. Not that he cooks much anyway. That's usually me. Okay, sorry. There we go. And now we can multiply here. So we're going to have, let's see, x to the 4th minus 10x cubed plus 16x squared plus 9x squared minus 90x plus 16 times 9 is 144. And then we can put our like terms together. So y equals, let's see, we have an x to the fourth minus 10x cubed. And we have some squareds in there, so plus 25x squared minus 90x plus 144. All right. That is a doozy. Whew. So pretty much this section is undoing everything we did the last 2 days on notes, right? Last 2 days, I started you here and was like, hey, find all the zeros. What are all the answers? And then you went back and you found me that, right? And now today, I'm like, hey, here's the answers. Where'd they come from? So now you know how to do it both forwards. All right, so there is a worksheet that's going to be attached here, so you guys can go ahead and work through that. All of the answers are also posted, so you can see my work shown. Something that you may want to jot down if you've not written down anything else, just kind of bring it all together here for you. So if you have a radical, right, we know they're plus minus. Those always came from x squared minus, and that was the number under the radical. And if you had an I, we knew those were plus minus, and those would be x squared. I am a positive person, and then you were to square the number with I. Right? So hopefully that makes sense. Just give yourself a little side note there. There is 2 questions on homework real quick, just because I know in years past students have always had questions on. It's asking you what the least degree is. So for example, if I would give you answers of -3, 4i, and negative radical 3, and I asked you what is the least degree that that polynomial could have, well, I know that an I answer is plus minus, and a radical answer is actually plus minus. So here's 1, 2, 3, 4, 5 answers, so that would be 5th degree. All right, so just take a look at how many answers you have. If there's a radical or an I, that's 2 answers because it's plus minus. Count up how many answers there are, and that's what the least degree would be, okay? All right, so if you guys have any questions, let me know. Again, I am always available, even if it's not during our normal meeting time. If you want me to do a video chat with you to go over some things, I am happy to do that. You are not bothering me in the slightest, okay? So feel free to reach out. I am happy to help if you need me. Otherwise, make sure everything's done by Sunday at 11:45 p.m. All your quiz is for each video that I post and the end of the week quiz as well. All right, guys, we will talk to you later.